All right. Number 1, evaluate the expression 20 divided by 4 minus, and then in parentheses 10 minus 8, close parentheses, close the other parentheses, and then you square your outer parentheses. So, I told you somewhere on your paper you should write P-E, parentheses, exponents, and then multiplication and division from left to right. There's no order there. Whatever comes first. These are evaluated at the same time. So it's not parentheses, exponents, then multiplication. It's parentheses, exponents, and multiplication and division from left to right, and then addition and subtraction from left to right. This is where most people mess up. Alright, so let's begin to solve this. Alright, so we've got these outer parentheses. So we're going to close those off, and that's going to be our entire universe right now. 4 minus, and in parentheses, 10 minus 8. So inside of the parentheses, we still follow PEMDAS. So we've got parentheses, so we evaluate these parentheses first. 10 minus 8 is 2. So we can rewrite this as in parentheses, and then don't forget about your little exponent here. You're squaring what's inside the parentheses. We're going to write 4 minus, and then 10 minus 8 is 2, so that's 4 minus 2. 4 minus 2. And we'll write 20 divided by. Notice I'm going step by step. All I've done right now is evaluated what's inside these inner parentheses. Now, I've simplified what's inside the parentheses. I'm going to evaluate what's in everything in the parentheses. So 20 divided by, and now 4 minus 2 is just 2. And then I'm not going to forget about my exponent. Now that I'm done with the parentheses, I'm done with this step, I move on to my exponents. 2 squared is 4, so I'm going to rewrite my whole expression again. If you try and do this in your head or skip steps, you're going to make a mistake. 2 squared is 4. And now we're just left with multiplication and division. We only have one of those. We've got division. So we put a little rectangle around that, and then we simplify that. 20 divided by 4 is what? 5. And so your answer is 5. Number 2, evaluate the expression 100 minus 4 times 7 minus 4 cubed. So again, what do we do first? We evaluate what's inside of the parentheses. 100 minus 4 times, and then we still have to retain the cubed, and then 7 minus 4 is what? 3. We've done our parentheses. Now we move on to exponents. 3 raised to the third power is 100 minus 4 times, and 3 to the third power is 27. Now, what comes next? We've done our parentheses, we've done our exponents. Now, multiplication and division from left to right. All right, so I told you with your pen or pencil or whatever, or with your finger, I want you to point to every single operation. So the first operation is a subtraction sign. We can ignore that. And the second operation, although it's not written here, you know that 4 next to parentheses 27 is multiplication. So let's do that. And we know that that is 108. So that is 100 minus 4 times 27 is 108. 108. And now we just do subtraction, and that gets us negative 8. So our answer is negative 8. Oops, that's too much. Number 3. Evaluate the expression negative 3 cubed plus 4 times 5 plus 15 divided by negative 3, and then you square all of that. So we do our parentheses first. So our world right now is just this. All of that. Don't worry about the squared. So let's do that. Let's do all of this, all of that, and then let's write a little squared there. Now, Within our parentheses, we follow PEMDAS. We don't have any parentheses inside of the parentheses, but we do have exponents. We've got an exponent right here. Now, I'm sure most of you are going to use your calculator, but it's important to remember if you are raising a negative number to a power, if the power is even, like 3 squared or negative 3 squared, then you are multiplying a negative number by another negative number. 2 negatives equals a positive, so that's going to be positive 9. However, if you're raising it to a power that is odd, you're always going to multiply a negative number an odd amount of times. If you're multiplying it an even amount of times, the negatives are always going to pair with each other, which means your result is going to be positive. But if you are raising it an odd amount of times to the third power, to the fifth or seventh or whatever, your result or your answer is going to be negative. So negative 3 times negative 3 is positive 9. Now let's do that. Let's write that out. Negative 3 times negative 3 is positive 9, but when you take positive 9 and you multiply it by negative 3, you get negative 27. So this first term over here is negative 27. And then we write out the rest of our expression. Plus 4 times 5 plus 15 divided by negative 3. And then we're going to square that. But we're still evaluating what's inside the parentheses. We've done parentheses. Well, actually, we're still in parentheses, but inside the parentheses, we've done parentheses, we've done exponents, and now we're doing multiplication and division from left to right. So that's exactly what I want you to do. So we're starting on my left, and I'm going through. I get to a plus sign or an addition sign. Don't care about that. I get to a multiplication sign. I do care about that. I'm going to evaluate that. That's what I do first. So negative 27 plus, and what's 4 times 5? 20. Plus 15 divided by negative 3, and then we're going to square all of that. Next step, I'm still on multiplication and division from left to right. All right, I see an addition sign, don't care about it. Another addition sign, don't care about it. I see a division sign. I do care about that, so I'm going to evaluate that next. And then I simplify even further, negative 27 plus 20 plus, and what's 15 divided by negative 3? That's going to be negative 5. And then we're going to square that. And now I'm going to skip some steps. Well, I'm not really skipping steps. Negative 27 plus 20 is negative 7. And then minus 5 is negative 12. So all of that stuff in the parentheses reduces to or simplifies to negative 12. And then negative 12 times negative 12, you're raising a negative number to an even power, so that's going to be a positive 144. And there's our answer right there. Number 4, evaluate the expression for f of negative 3. Oh, I shouldn't have said expression there. That should be equation. Sorry. That's what I get for copying and pasting. So we know that, all right, if f of t equals 2t cubed plus 14t squared minus t, and we know that f of t is negative 3, then f of t, or f of negative 3, equals 2 times negative 3 cubed plus 14, and then we put the negative 3, and we square that, and then we subtract negative 3. It helps so much if you put the value of your variable in parentheses, so you don't make mistakes like this. See, right now it's very clear that you have minus negative 3, whereas if you just put negative 3 here, you might have just written negative or minus 3. So now this should be easy. Negative 3 cubed is 2 times negative 27. And this is just plus negative 3 squared is 9, so that's going to be 14 times 9. And then minus negative 3 is plus 3, and that's pretty simple. So 2 times negative 27 is negative 54. 14 times 9 is 126. Oops. 126. And then you're going to add that to 3. You're going to add 3 to that. And you can use your nifty little calculator. Minus 54 gives you 75. Let me double check that. 120, negative 54 plus 126 plus 3. Yeah, that's right. Number 5. What is the value of z if x equals 2 and y equals 3? I told you the hardest part of these questions is just writing it down correctly. So x is 2, 2 minus, and then this is 2 times y is 3, 2 times 3. And then you're going to raise all of that to the x power, which is 2. You're going to square that. Then you're going to divide that by x, which is 2. Ooh, isn't this fun? So what do we do first? We do our parentheses. Remember, simplify. If you've got a fraction, always simplify your fraction. So inside the parentheses, we've got 2 minus, and then we do the multiplication first. 2 times 3 is 6. So let's write that. Let's do it step by step. 2 minus 6. We're going to square that over 2. And then we know that 2 minus 6 is negative 4 squared over 2. And we know negative 4 squared is positive 16 over 2. And that equals, you guessed it, 8. Easy. Number 6, evaluate the following expression. Look, there's not even variables here. All right, let's do our exponents first. 2 squared is 4, plus 3 squared is 9, times 4. And then, although we could concentrate on that, let's do the exponents all over the expression. 5 squared is 25 minus 3 times 5. And now we can begin to simplify that. I'm going to continue this over here. So let's do the top of the fraction first. We've done exponents. Next comes multiplication and division. So we'll look at our signs. That's an addition sign. Don't care about it. That's a multiplication sign. We do care about it. 9 times 4 is 36. So 4 plus 36. And that's going to equal 40. And then let's evaluate the denominator. We don't care about the subtraction sign yet. We care about the multiplication sign. 3 times 5 is what? 15. So we write 25 minus 15, and that's just 10. And 40 divided by 10 is 4. You better get this next one correct. This is simple. Formula for converting degrees Celsius to degrees Fahrenheit is that whole mess. What is the temperature in Fahrenheit of 20 degrees Celsius? You want to know F, 9/5, when C is 20. So this is pretty simple. This is just okay, so we can write 9/5 times 20 over 1 plus 32. And then that's pretty simple. 9 times 20 is 180 over 5 plus 32. And I'll just continue this here. 180 divided by 5 is 36. 36 plus 32. Oh, drop my pen. It's 32. Oops. And that gives us 68. And there's our answer right there. 68 degrees Fahrenheit. Number 8. Suppose 40 cars start at the Indianapolis 500. In how many ways can the top 3 cars finish the race? Well, how many choices are we making here? So we can, if we're trying to figure out how many different common permutations there are, we'll choose a first place car, a second place car, and a third place car. That's 3 choices. How many possibilities are there for the first choice? There's 40 cars, right? But once one of those cars comes in first, we only have 39 left to choose from, and then 38 left. Oh, you multiply all those together by themselves, 40 times 39 times 38, and you get the small, modest value of 59,280 different combo or permutations. These are permutations, not combinations, because order matters. You know, you would care if you got first or second, especially if the prize was money. Number 9. A coach must choose 5 starters from a team of 12 players. How many different ways can the coach choose the starters? How many starters is the coach choosing? 5. He's choosing a starter, a second, a third, a fourth, and a fifth. How many different permutations? How many choices does he have for the first starter? 12. Then for the second, 11. For the third, 10. For the fourth, 9. And for the fifth, 8. And then you multiply all those together. 12 times 11 times 10 times 9 times 8. There are 95,040 different permutations. There are less combinations, and I can understand if you might think that this is that you might think that order doesn't matter here, and in some ways that's true. But on the MSA, every single question every single question you're going to be asked, when they say outcomes, how many outcomes, you're assuming that order always matters. So there are always going to be less amount of combinations than there are permutations, but you first need to figure out how many permutations there are to figure out how many combinations there are. But we're only learning about permutations. Number 10, Pete has 5 different ties that match with 3 different shirts. How many different shirt and tie combinations can he make if he selects one shirt and one tie? So how many choices is he making? He's making a first choice about shirts, and a second choice about a tie that goes with that shirt. So how many shirts does he have to choose from? 3. There are 3 possible shirts. For every shirt, he can pick one of 5 ties. So how many different combinations? Well, that shouldn't say combination. It should say permutation. There are 15 different outcomes for this outfit. Number 11, what is the area of the figure below? I told you, whenever you have a composite figure, I want you to break it down into its component figures. So the area, the total area, equals, let me make it nicer, equals the area of a rectangle, this rectangle right here, plus the area of a half circle, that's a half circle, not a D, plus the area of, let's say, a small triangle. Well, actually, it's 2 times the area of the small triangles here, these small triangles, plus the area of a big triangle. So we've got 4 different shapes or 4 different calculations. All right, let's find the area of the rectangle is just going to be length times width. The area of the half circle is going to be the area of a circle, pi r squared, and we're just going to cut that in half. The area of one triangle is going to be 1/2 base times height of those. I'm sorry, hold on one second. We're doing that 2 times. 2 times 1/2 base times height. And then we're going to add that to, we're going to add another triangle base times height. So let's figure out what what our numbers are. The length times the width of the rectangle is 10 times 15, which is just 150. Let's find the area of the circle. We know that the diameter of the circle is 15, so the radius is going to be 7.5. So we can plug that in. We're going to add this to pi times 7.5 squared over 2. Let's leave that alone right now. Let's get our numbers in first. Then 2 times, and we're doing 2 times because you see this triangle right here? It's got a base of 10 and a height of 6. So does this triangle, base of 10 and a height of 6. So we have that 2 times, right? We have the same triangle 2 times. So that's 1/2 times the base, which is 10, and the height, which is 6. And then we're going to add to that this other triangle with a different base and a different height. 1/2 base, which is 15, and a height of 6. And now we can figure out what each part is. 150 plus, and then you can use your nifty little calculator, 7.5 squared times pi divided by 2 gives you 88 point, oh, that's a lot of decimals, 3125. Then we're going to add to that 2 times 1/2, 10 times 6. So we can do this in our head. 10 times 6 is 60, times 1/2 or divided by 2 is 30, times 2 is 60. And then we're going to add that to 15 times 6 divided by 2 is 45. And all of that equals 45 plus 60 plus 88.3125 plus 150 equals, oh, this is fun, 343.3125. And I'm sorry I didn't give you units, but whatever units they would be, let's say centimeters, they would be squared because it's 2-dimensional. Number 12. An above-ground pool has a diameter of 20 feet and a height of 7 feet. What is the volume? Well, volume equals, well, let me use my blue color. Volume equals base times height. The base of a pool like this, what solid is this? It's a cylinder. So we have to find the area of the base, which is a circle. So the area of the base is going to be the area of a circle, pi r squared, times whatever the height is. And now we just fill in our values. Pi, what is r? Well, if the diameter is 20 feet, then r is 10. That's 10 squared. Times the height, which is 7. That's 10 squared is 100. 100 times pi is approximately 314. And you multiply that by 7. 314 times 7 gives you 2,198, what is this, feet? Feet. And then because it's 3-dimensional, we say feet cubed. And there we are.